we now move to the next part of the conference, which will be about typical products, solutions, and devices. So I'd like to invite Purnima Shandilya and Arindam Bhattacharya from CDOT India to please present, showcase their CDOT Common Services Platform. Before we start, a brief introduction to Purnima. Purnima is currently the team leader at CDOT and also the oneM2M STS Vice Chair. She has over 15 years of experience in various telecom technologies. She currently leads the design and development for CDOT's CCSP platform, which is what we're going to be talking about today, and is also a part of the Center of Innovation team for IoT M2M, which is engaging with the IoT M2M industry, startups and research partners from India. She also leads the oneM2M task force for development of test purposes and test cases for oneM2M Release 4. Arindam is oneM2M Vice Chair. He is also from CDOT. He is an electronic engineer with over 34 years of industry experience in varied fields of computing and communications. Currently, he leads the activities of IoT M2M communications in CDOT, and he has been a key contributor to various policy and roadmap documents of DOT, Department of Telecommunications, Government of India, on M2M communications. Over to you, Purnima and Arindam.
Good evening, good afternoon. Thank you very much for the introduction, and thank you for this opportunity. And thank you TSDSI and TTA for hosting this event. And speaking here feels like home. oneM2M's community has been very supportive and helpful. I'm happy to share about our CCSP platform. Okay, I'll share the screen. So CDOT Common Service Platform is a oneM2M standard-based common service layer developed by CDOT. So this is the brief outline of my presentation, that I'll be sharing common service functions supported by CCSP and its advanced features and various portals that we support along with CCSP, and that events that we conducted using CCSP, and our Center of Innovation Initiative in India using CCSP, and various types of applications that have registered with us, and those applications which are in onboarding process. And if the time permits, then we'll have a live demo video play that we did in the IMC, India Mobile Congress 2022. So before I delve into the details of CCSP, I would like to share our motivation behind the development of our platform. So we got engaged with oneM2M in 2015, and by then, concept of IoT M2M, things interacting over internet and machines talking to each other, was already there for almost 2 decades. And there were already implementation deployments in the field, but oneM2M concept of that it has a common service functions which are exposed as API and which are reusable components, and different applications, different verticals can use it, and it can create interoperable solutions, and different vertical can share. So this is a very strong value proposition that it offered, and that was our motivation to start with our development. So in 2016, we had our first prototype, and the formal development we started in 2017. So initially, we started with just 5 CSFs, which were registration, discovery, group management, data management repository, and subscription and notification. So these 5 CSFs were enough for most of the use cases we did, or most of the demonstration we did, like to receive data from sensor and actuate the device and to display some data on dashboards. So we were able to perform those use cases. Then later on, when there was need, that there was question that how secure is your platform. So then we started working on the security CSF and so on. So these are the key highlights of CCSP, so that it is compliant to oneM2M Release 3 specification with support of some advanced Release 4 features. It supports 11 common service functions, and it supports PSK and certificate-based TLS security. And it's RESTful resource-oriented APIs, of course, it's because it's oneM2M compliant. So it supports XML and JSON data formats, and it supports HTTP, QAP, and MQTT protocol bindings. And it has advanced functionalities. So these are the advanced functionalities which are supported by CCSP. So in the interest of time, I won't be able to discuss the need for all of these advanced features, but I will try to discuss few. So 3GPP interworking and NB-IoT. So CDOT has developed its indigenous 4G and 5G core. So for a demonstration for the POC purpose, we were required to develop the NB-IoT functionality. So since our team was involved in the IoT platform, so we also did the development of SCEF functionality of 4G core, which is Service Capability Exposure function. So we had to develop the NID functionality, and we were happy that the NID functionality the oneM2M specification was very well defined in the 3GPP specification, and 3GPP interworking was very well defined in oneM2M. So using both the specification, we could develop our SCEF as well as NB-IoT functionality, and we could perform end-to-end demo and the POC of the this functionality. So that was the motivation for 3GPP interworking. And the Flex container, when there were many applications that were coming, they had very complex models, and we realized that in the long term, having these many containers, it won't work. It is important to have data models. It is important to have their XSDs defined. So we started the development of Flex container. Then the field device configuration. So for every device, we need to provide them some configurations, like who is their registrar, what are their credentials. So field device configuration TS22 specification allowed us to create those configuration and configure those configurations on the devices, so that they can talk to our platform in a secure way, and they have those configurations configured on them. And then we have this support for MN and ASN configuration. So here we are not just supporting MN and ASN, but we are also supporting MN and ASN along with its registry information. So our MN and ASN knows that who or what is the subscription details of the registry which are coming to it. So what all registries are coming to it. So with these kind of functionality we support. So from release 4, we support primitive profile, service restrictions, service subscription linking for field nodes. So motivation for primitive profile, again linked to the NID functionality. In the NB-IoT use case, the size of data payload was very small, and we realized that the typically oneM2M payload size is more than 500 bytes. So it's better that we have a primitive profile functionality in place if we have to reduce the payload size. So again, then the service restrictions is related to the activation, deactivation of services of a M2M application provider. So using this, we can define number of applications, number of nodes, number of containers, number of subscriptions for an application provider. And linking allows us to link service subscription with its applications. So these are some of the portals which help CCSP and the industry and the application provider. So first we have industry partner engagement portal, wherein industry partner can register, can provide their application information, can provide their device information, and based on that, provisioning can be done. Once the information is provisioned, their service subscriptions can be created, and users in various roles can be created for M2M application provider. So they could be admin user for M2M application provider, they could be a normal user. So they'll have different screens or different UIs to view. Then we have resource reviewer. So for each subscriber, they can view all the resources which belong to them. And then since we support device management also with TR069 and LWM2M, so we have network management application wherein we can view all the devices, battery, memory, or firmware information using our network management application. And recently we implemented a very good feature, which is application resource management, which is specifically for constrained devices wherein it's not possible for them to create all the hierarchy, because in the context of devices, if we think their main task is to send data. So if we force them to create AE, container, and all the hierarchy, it's a lot of work for them. So using our application resource management, we create all the hierarchy for them, and the application just has to focus on creating the data. So these are the main products, the main solutions that we have: INCCSP, MNCCSP, ASN CCSP, portals. So all these are offered in the form of containerized images, which can be deployed in any cloud-based environment or any Docker Kubernetes setup. So this is just numbers with respect to CCSP. So we have hosted 2 developer events and 2 workshops with CCSP, and we have participated in 5 interops and interoperability testings. And we have done interoperability with 10 organizations, and we have done more than 20 demonstrations with CCSP, and recently 35 parties have collaborated for us onboarding to CCSP. So this is Center of Innovation initiative, wherein we engage with industry partners within India, and we not just help them to develop oneM2M compliant application, and we just not then provide platform, but we also provide them complete environment. So within our CDOT premises, we have a lab, COI lab dedicated for IoT M2M development, which is recently inaugurated by our Honorable Minister of Communication. So here we have all the support environment, and we have our engineers also to help application provider to make their application oneM2M compliant. And at the end of the testing, we also provide them certificate for successful completion of testing. So this is just to encourage them to understand and to make oneM2M compliant application. So this is a brief areas of application that have registered with us. So we see that the maximum applications that have registered are in the surveillance, 24%, and then we have transport, the second candidate, and third candidate is smart home, and fourth is safety and security. These were the maximum applications that registered. So out of these many verticals, initially we started with these areas: asset tracking, smart home, smart metering, surveillance, transport, smart street light, to understand the problems or the deployment scenarios of different use cases. So these are some of the examples. So this is a fire compliant fire safety solution with one of the partners that are integrated with CCSP. So this is deployed within our campus. So this is example of Modbus interworking, and the IP is sitting on the fire panel, which in turn talks to the CCSP platform, and then its dashboard application again gets the data from the CCSP as an AE. So this is another example where solutions from IGN, they have street lights, they have street support of RF mesh or NB-IoT or 4G, 5G on their street lights, and again they talk to the gateway, and gateway in turn talks to our CCSP, and the various lights can be monitored using their dashboards. And this is one of the innovative solution, which is for digital ocean. This was very different use case. So in this case, they monitor the basically the underwater devices can be installed within the ships, so that the ocean data can be gathered and further research can be performed on the ocean data. And there they have the life safety watches also, which can be used by fishermen. And another solution that we have from CloudWorks, which is building digital twin. So they have their, they can convert any building or they can create digital twin for any building or having sensors and actuators, and can using their animations and 3D models. So initially they are planning to convert our smart living application and our campus into a digital twin using their application. So it will be installed as an INAE. So this was the use case that we did in the IMC 2022. So here we have 5 applications. One is the fire application, which is from, sorry. So one is the fire application, which is from Pyrox, and there are emergency exits, and there is a Samvad application, which is an in-house developed by CDOT, similar to WhatsApp, and there is a Wayfinder application, which is for in-house navigation, and there is a fan is depicting here AHUs and ACs.
Fire safety.
관리사무소에서 동파 예방 안내 말씀드리겠습니다. 갑작스러운 추위로 입주사 내부 창문과 휴게 공간 창문이 고정돼 있으면 또 시설 및 스프링클러 시설이 동파될 가능성이 있습니다. 사무실 마지막 투실자분들은 사무실 및 주변에 개방되어 있는 창문이 있으면 반드시 닫아주시고 투실해 주시기 바랍니다. 다시 한번 안내 말씀드리겠습니다. 갑작스러운 추위로 입주사 내부 창문과 기계 공간 창문이 개방되어 있으면 또 시설 및 스프링클러 시설이 동파될 가능성이 있습니다. 사무실 마지막 투실자분들은 사무실 및 주변에 개방되어 있는 창문이 있으면 반드시 닫아주시고 투실해 주시기 바랍니다. 감사합니다.
Apologize for that interruption. There was a public alert announcement. We can continue with the session. Purnima.
Just before leaving the office, they closed the door because of cold weather.
Okay.
Sorry for the interruption. So yes, so these we demonstrated that how these 5 applications of different use cases interacted using our CCSP platform. So in the event of fire, the information is sent to CCSP, which in turn sent to all the applications, and the emergency exit is open, and this all the person within the building are notified for the fire event, and safe exit route is shown to them to evacuate the building, and all the HUs are stopped to avoid spread of smoke. So I could not add the slide for COI. So you can go to https:/coi.c.in for registering and to know more about our platform. And we have added a lot of guides for the new developers, which are really helpful. And we have also added reference to oneM2M. Thank you very much.
Thank you, Purnima. And very interesting. The moment Purnima mentioned Wayfinder, there was this alert saying, please shut the doors before you leave. In the interest of time, the video that you wanted to showcase, if we can give a link, we will put the link in the chat and communicate it to all the participants, and also put it on the event website. People can view it on offline. Yeah, thank you. Am I presenting?
Yes.
Okay. Next, we will have a talk by Andreas Kraft on device data orchestration using oneM2M. So Andreas is currently the principal enterprise architect IoT at Deutsche Telekom. He has studied computer science at the Technical University of Berlin, Germany. Since 2000, he's been working for Deutsche Telekom in various research and innovation projects in areas such as connected home, elderly living, edge computing gateways, software execution environments and modularity, and remote management, etc. Andreas has, apart from contributing to the standards, also created several resources for which researchers can leverage for developing oneM2M applications. And I'd also like to announce Andreas Kraft has just been awarded the oneM2M Technical Excellence Award for developing over to you, Andreas. We'll run your presentation.
Yeah, thank you very much. First of all, thank you very much for organizing everybody who's involved in organizing this conference and also for hosting here. I think it's a wonderful facility and moment here to come together at the end of the year. Thank you very much for that. So I will present a development done inside of Deutsche Telekom, the device data orchestration, device management orchestration using oneM2M. Next slide, please. This presentation is usually held either by my colleague Andre Dutra or by myself. So that's why both our names are on the slides. So some of the key technology hurdles that we experienced within our IoT unit are basically those four here. That we have multiple platforms, not only operated in our facility, in our by us for our customers, but also what customers operate in addition or basically use in addition. Also interfacing with legacy IT systems is a big problem. So because of all the investments that have to be, I don't know, written off or new developments have to be taken in order to connect to those systems. The lack of standardization for IT solutions is tremendous at the moment. So we have hundreds and hundreds and even thousands of systems, different solutions. Everybody's well using standards like, of course, transport standards like MQTT, like HTTP REST, and so on and so on. But they are all different. They have all different ideas, different kind of authentication, identification. Basically, the fragmentation that Raina mentioned in her presentation, that is basically just also not only in security, but also, of course, in technical and systems to interconnect. And this is basically then the problem number 4, the business intelligence and analytics to do. IoT data is very, very hard. So basically to integrate both the different IoT data that we see from the devices, different units of measure, for example, how the data is actually structured, what does it mean, is not very clear all the time. It is clear by historic reasons, just by documentation from business systems, but currently in IoT, it's really, it's not that easy. Next slide, please. So for us in Deutsche Telekom, we are not necessarily a cloud provider. We are offering this, of course, to our customers. We are providing a couple of systems, especially for enterprise system, of course, and also over the years, we also offered a couple of IoT solutions here. The problem that we are facing is actually how to connect the IoT world and the connectivity. So that means SIM card management, device management, network management, all these kinds of things, how to organize these kinds of devices, how to bring this together, especially in the area and the topic of IoT. For that, we are currently deploying, or we are currently implementing something which is called IoT Hub, the IoT Hub for Deutsche Telekom, and offering basically 2 different main standards in this industry. One is the TM forum for the connectivity management, for the orchestration, because we are not only operating in our footprint, but also, of course, IoT in worldwide as a global provider, especially for IT, which makes it especially interesting for global customers, of course, which are, for example, container management, logistics, manufacturing, all these kinds of providers here. For this, the TM forum already provides nice standards, good standards, and actually to do the connectivity management. But for the IoT, for the device management, we decided to use oneM2M because of the flexibility we have, not only for the device management itself, but also later basically to enhance it step by step, whatever the customer needs in order for going further for the for IoT, more data-related organization and management. Next slide, please. We decided not to implement a whole CSE with all the functionality like Monima decided, but we focusing on only a handful of basic functionality, which is, I think, very interesting because you can start with just a handful of resource types. So we heard before from Roland how many resource types we have, around 80 plus all the specializations which are semantically a bit more advanced. but with just a handful of resources, you can already start your oneM2M deployment. So of course you need the CSE base, you need represents the CSE, the server in the middle, the back end, the application entities, and then you can start with a couple of sources that represent the devices that are the nodes, container for organizing the structures of the application of your data model and your information model, and of course access control policies in order to implement security as well as subscription for the notification. Yeah, I said it already. Why do we do oneM2M? Because it's just a standard API, and we really like standards because we are investing also in protecting our customers, of course, for a very long time. I think that's really, really important. So just a couple of months ago, like 2 months ago, Google announced that they're going out of the business because they're not having a big market. Like Google is like, even if they're only 10 or 15% of the IoT market, it's a huge number of devices which is now brick, basically, which means that customers need and application developers need to adapt to new solutions. And I think this is really it's a big problem. Here, oneM2M can very much help, of course, because no matter what, the promise is always use a standard, go to a different provider, and then you basically can just continue with your applications and your devices. Again, the oneM2M architecture and the specification, they first look very scary because there are dozens of documents you might have to read, you have to check thousands of pages. But in the end, if you look at the complexity that we already solved here with, with discussing for many, many years, this really, really fits together. And it's a really good specification that you can basically take. Of course, you have to do something development rules around that, but basically you already get a lot of technology for free that you can use in your developments. And I think this is true for backend developers as well as for application developers, because you don't have to decide on how to represent, for example, the temperature, or how to represent the device. And again, we are thinking that oneM2M is really broad and provides generic capabilities that are mappable to any oneM2M platform. I think this is really, really nice to have. Next slide, please. So this is basically our current implementation. As I said, we are just taking a few functionality of oneM2M and developing it further and further on customer demand. This is basically what you're seeing here is out of the box provisioning of an AE and basically supporting lightweight M2M because this is what our customers currently demand. We are integrating deeply with our BSS and OSS system, for example, for SIM card and device management and charging and so on, all these kinds of things. We are providing user interfaces, we are providing network connectivity and integration to our own backend IoT systems that you already have from the traditional way. Basically, have the ability to move over customer step by step or even function by function, so that, for example, the data can still reside on something which is called Cloud of Things, which is a velocity platform, if you know that one, or hyperscaler APIs, for example, connecting to AWS or similar things. So basically, we have a hybrid system here, and for example, offering on device management, device registration, and bootstrapping via oneM2M, but the data heavy lifting of the data processing is still done then, for example, on AWS. Next slide, please. Just as an example that we also showed at the IoT Week 2 months ago, it's basically device provisioning. So we just take device provisioning here. We have the hyperscaler API and the device provisioning AE that actually does the work. So for example, we can go both ways. So for example, if a device register that we don't know yet, we are able to connect to our OSS BSS system, for example, to buffer it first, or to just put it aside, and then the customer then registers it afterwards. I look, this is my device, this is my SIM card, and it's fine. Or the other way around. So for example, pre-provisioning devices that we can, like by provisioning, for example, like thousands of devices, and a customer orders them and either use them directly or later on. This can be done through this interface, and no matter what, it depends on the customer, of course, how the connectivity goes, where the data is actually sent through, but the device management happens through oneM2M here. Next slide, please. Is this an animated slide? No, okay. This is an example for automatic data collection, and we're using, for example, Lightweight M2M. This is also based on TS14, which is a standard, basically giving information about how Lightweight M2M and oneM2M play together, how they can be interoperable. And here what we are doing is we have Lightweight M2M devices that are bootstrapping, that are registering through a normal Lightweight M2M means. And then the nice thing with Lightweight M2M is that they automatically provide the data structure. For example, what is data for the battery, what is temperature data, something like that. This tree is here, it's being reported by the device. And this is a really nice thing because we can automatically build up the structure without any kind of customer interaction. So no need here for the customer to build up a container structure, something like that. This is something that we can automatically build. Also kind of like a convenience functionality. But I think it's a good example how well two different technologies, or one technology which is Lightweight M2M, for example, that provides certain capabilities, is able to play with oneM2M, and how basically can provide value for our customers here. Next slide, please. Okay, coming to the end, what is the current status? As I said, the device management orchestration, this is already done. We're providing this in a carrier-grade installation. It's multi-tenancy, of course. We can have multiple installations for customers, either also for multi-region or all these kinds of things. This is not a big problem. We have a comprehensive live API documentation in Swagger, which is a bit unusual, I have to say, for oneM2M, because it's a REST interface. Everything is RESTful, but it does not really, in an enterprise way, where you have fixed paths for developers to follow to retrieve certain documents, because everything is a bit more dynamic here. But we found that actually developers that we are working with our customers are actually more used to enterprise-like tools and so on. And here Swagger, of course, is the main functionality or main tool to go at how to understand the functionality. Everything is live behind that. So for example, Swagger UI directly goes to the live system, and the developers can start basically developing on test systems or even on production, of course. Not that good on doing on production, but it's still possible. Again, we are currently doing proof of concept integrations with our Cloud of Things and AWS and other hyperscaler cloud services. And the further evolution of our offering here depends really on the customer demand. We are seeing what's going on here, and then we are talking and basically starting to develop. And we are welcome customers, partners. So we are actually also looking for any kind of partnership with anybody else. Thank you.
Thank you, Andreas. That was an example of a telco taking the initiative of using oneM2M for their internal IoT applications, and now the POC is also happening. We'll wait to hear the outcomes of those results, those activities. We now will have a presentation by Bob Flynn, William Flynn, on just a minute. Abilities and services.
Okay.
Yeah, so Bob will talk about lessons learned while developing oneM2M cellular devices. So Bob is currently the founder and principal consultant at Exacta Global Smart Solutions. He has over 20 years of experience in research and development in oneM2M and 3GPP global standards. He's an IoT expert, recognized for his ability to architect solutions for clients to meet project needs. He's also the vice chair of the Test and Development Ecosystem Working Group at oneM2M. Prior to Exacta, Bob was an architect for oneM2M at Cordant, where he led the oneM2M component of Cordant's One Transport project and the incubation of interworking oneM2M with 3GPP, 4G, 5G IoT capabilities. Bob is also currently leading some outreach engagements with certain universities, where he's mentoring students, undergrad students, on using oneM2M framework for their IoT M2M projects. Over to you, Bob.
Thank you. You'll make me the presenter. Okay, so earlier you heard Roland talk about one of the work items that we have, the effective IoT communications to protect 3GPP networks, right? In the development of that, we have some lessons learned while working with cellular platforms for IoT devices in general, and then also a little bit of how oneM2M makes that process just a little bit easier to realize. So this particular slide is one that I've talked about a few times, and in the past I've talked about it from the endpoint all the way after we're talking about the large-scale deployment of IoT devices on cellular platforms. I'm going to go into a little bit of background with that, but for the most part, I'm going to focus on the actual development on the cellular device today. So when developing IoT devices on a cellular platform, it brings into play a whole new set of skills that most embedded developers don't have today. There's a lot involved and a lot of specialized knowledge in not just the specific APIs, but the whole operation of cellular devices in order to do that well and to do it in a way that doesn't impact the mobile operators' networks in the first place. So what I'm describing here is, kind of the design life cycle. You'll start by designing your cellular device, and you'll work in the lab, you'll encounter some problems, you'll come up with some workarounds for it, and you'll be done in the lab. And then you'll go ahead and deploy that in a proof of concept type of thing, and generally that kind of works pretty well too. And then you get into a situation where you're confidently deploying large numbers of devices. But then some kind of error occurs. And an error in, say, a typical non-cellular embedded device, you might have built in some error handling for that. And in the worst case scenario, the same thing that we do whenever we have any kind of problems with any kind of computer, you would trigger some sort of reset, right? And when you do that reset, it's the same type of instructions you're given by your IT department. If something doesn't work, you reboot your computer and everything goes back to working normally, right? But when we have IoT devices, there's not a reset button. You have to have that done automatically, right? Because all these devices are out there deployed in places where people are not at, especially when we talk about cellular devices. Now, depending on the type of error, that can cause a single device to reboot, in which case you just come back up and everything is fine. But if the error occurs somewhere, say in the back end in the cloud, some sort of communication problem happens in the cloud, and you have a lot of devices that are experiencing some sort of error scenario, and then they all hit that reset operation, you have them basically all reconnecting to the network again, over and over again, and the communication networks are not designed for that. And this is a problem that we don't see today with our smartphones, because that kind of reset operation is triggered by a human being. When this is done automatically by a cellular device, you can wind yourself up into a loop where the device is just constantly rebooting. And that's because, again, that error may have been in the IoT application server in the cloud, and rebooting the device doesn't fix that problem. And the device doesn't know about that. You can't foresee that when you're deploying that device. So this is kind of a problem in, on the large scale, massive IoT deployment perspective. But let's talk about how that can possibly be fixed. How do we solve that? And GSMA tackled that problem, and they tackled that quite some time back, and they did that and published the results in a TS34 document, a GSMA document called IoT Device Connection Efficiency Guidelines. And the studies for that guideline showed was that the solution to this problem cannot be fixed alone in the cellular device. This requires an end-to-end system solution. From the cloud application server through the 3GPP mobile network and operations on the device. So TS34 has a whole list of requirements and test cases that should be considered when developing an IoT system that is using a 3GPP network. That could be a lot of work for that embedded developer team trying to build all of that, because now not only are they doing this for the device, they have to take into consideration the application server side and everything in between. That's a lot to do. That's expensive. It takes a lot of development, a lot of expertise, and these types of things, they're not in enough demand at this point. So GSMA came up with, they recognized that when they published this document, and they came up with an architecture to basically isolate the application logic from the communication logic. And when they did that, they defined their component, or in TS34, they identified an embedded service layer that would go on the cellular device, and then also an embedded, a service layer up in the cloud. If you look at the oneM2M architecture and the things that we've talked about earlier today, this is exactly the way the oneM2M architecture is defined and developed too, or at least one of some of the deployment options. So there's a very good synergy there. So what I'm showing here is, again, in that end-to-end scenario, just an example of one of the use case scenarios that that can be resolved using the oneM2M as that service layer to solve or to implement all of those requirements that GSMA has defined. And again, I'm not going to go through the entire call flow, but basically what this call flow defines is you're setting up a policy that the cellular devices will communicate based on. And this policy can be defined by the needs of the IoT application server, the business logic for this particular device, and then also managed and supervised by the mobile network operators. And then what this allows us to do is, when the core network is having some problems, the mobile network operator can come in and proactively modify the policies that the cellular device is communicating with to avoid the problems that could occur if you weren't able to do that, such as significant or severe blackouts or communication failures that affect large numbers of end users, not just the IoT devices, but all the human users of smartphones and all that, because they're all using that same communication architecture. But again, earlier I said, I kind of wanted to dig into a little bit onto the device side. So this is kind of just this is the background for all of that. On the cellular IoT device side, how do you take this into consideration? And there's a lot of pieces there that our new developers in this domain have to become familiar with and aware of. In order to kind of show this type of concept, one of the things that I've been doing is working with the university that I had gone to, Penn State University. I sponsor some projects with the senior engineering students there, and what I've done is I'm having them develop cellular IoT devices and communicating with a oneM2M server in the cloud. I have an example of a recent project related to that on Hackster Hackster.io that they used for the hackathon that was just recently completed. And in that particular article, you can see a lot of instructions and the details and the Git repositories for some of the things that they went through in implementing that. In order to do that, we found a cellular IoT device. The one that we were using for this was from Nordic Semiconductor. They have a nice little device called Thingy 91. What's nice about it is this Thingy 91 has a chipset for the cellular communication. That's their 9160, and then there's an additional chipset on this device for other types of local communication, like Bluetooth. This chipset has a GPS receiver on it, has a handful of different sensors, so it's a perfect little prototyping board for cellular IoT. They call their default out-of-the-box application an asset tracker, and as soon as you turn it on, it can work like that. So what my students have done is they've taken that asset tracker and they basically implemented a couple different IoT projects using oneM2M, and then a large numbers of lessons learned from this. And one of the there's a couple different directions I'm going to go with the lessons learned. There's the lessons learned from what new engineers who know a bit about IoT communications. They have experience with embedded devices like many of us do, the ESP32s, Raspberry Pis, a lot of things like that. But the challenges that they experience when trying to take that kind of knowledge and put it onto a cellular device, it brings challenges. I tend to say obvious because it's obvious to me because I know a little bit about cellular programming. But when you're developing, say, an IoT device on an ESP32, quite frequently you're going to put a little web server on that. As soon as you try to do that on a cellular device, you find out right away that you cannot do that. In fact, with the Nordic chipset, there's not even an API for doing a web server, which is proper because you don't want a cellular device establishing an always-on connection. That's not a good way to communicate over a mobile network. This is not something they know coming out of the box, and that's just the start. But take a step back and think about all the things that are involved with building an IoT device and getting that to work in the first place. You're dealing with a lot. You're dealing with a lot of different choices that you have to make. Just some of the basic choices are, are you going to use TCP or UDP for your communications? Are you going to use TLS or DTLS for your communications, or are you going to use PSK for the security of those communications? And then as you move it up, you have the choice between MQTT, CoAP, HTTP. These are all examples. And then XML, JSON, or CBORD. There's lots of different choices that you can make when choosing how to do this on a cellular device. And all of these decisions are extremely important on a cellular device because power is a major problem. Again, the use case for a cellular IoT device is something that's kind of out there, unmanned, unaccessible, something that you don't have to go see very long. So every one of those decisions has a direct impact on the power used by that cellular device. TCP is much more expensive than UDP. So what we tend to use in that ESP32 as an example, you probably don't want to do that on a cellular device because it becomes a lot more costly in terms of power and communication. How you secure it. If you're using TLS or DTLS, that's a fairly expensive with all the handshakes that go back and forth. So maybe you want to use something like pre-share keys for your security. These chipsets, like for example the Thingy 91, they have libraries for MQTT and CoAP and HTTP on it. But again, it's another decision that has a direct impact on the power used. And likewise, I mentioned XML. I think we all know that would not be a choice for not even an ESP32 at this point. But JSON is very common. You see that a lot. But CBORD's yet a better option for working on a cellular device because it's even more efficient than JSON. Now, as you go through these choices and make these decisions for cellular deployment, this is where the benefits of oneM2M really start to shine, because I can make all these choices. I can have my original prototype on an embedded device, and I could have chosen HTTPS over, using a TCP channel, using HTTP protocol and XML. I could have made that choice for that decision. Come and learn that none of those are good choices for a cellular device. Make my changes on the cellular device. Now, in a IoT deployment, when you make all those changes, you're changing the platform that you were speaking to in the first place. So there's a lot of changes that have to propagate through that. That's one of the things that oneM2M brings to the table that you don't see with these other with other types of technology. oneM2M supports all those variations for all the different devices. So making that quick change on a cellular device, it's already supported by a CSE that's developed in the cloud. So you can make that choice, and there's no corresponding update in the cloud that needs to be made. There's no corresponding update to the applications that you're developing along the way. Now, another thing to highlight with all this, all these characteristics that that I kind of just described that are choices. If you look at this, I think it's the second link here that is published by Nordic Semiconductor. They describe these choices in there too. So those choices are the level of discussion that even in the chipset providers are being provided. Yet it still leaves our developers with a big problem, because again, it's they're going to have to make, as they make these smart choices for the cellular device, there's the corresponding changes in the application logic that would have to occur too. Again, things that are avoided when you're using oneM2M because it handles that on a per device or per device basis. So that's really, I would describe that as some of the key takeaways that that I've seen the students observing as they're using it, and some of the feedback that I've gotten from them, related to this. This is all on the application side, just developing a simple sensor. If you if we think back to a couple slides that I mentioned earlier, the amount of services and capabilities that become available using oneM2M, further increases because it's more value-added services. The things in that TS34, for example, they talk about not sending a message. Every time that sensor value or that sensor detects a value or measures a value, you don't want to send it immediately. You might want to bulk or aggregate those up so that you're not turning that device on all the time. These are things that, again, when you're working with a MCU type of thing, you don't encounter that problem. On a cellular device, this becomes a problem that you have to deal with, and these are all things that are addressed in the work item that we mentioned before, the protect the network communications. So with that, thank you for your time, and if you have any questions.
Thank you, Bob, for showcasing actually implementation in a massive cellular IoT ecosystem, and how students were encouraged to address the problems through the very elegant oneM2M framework. So with this, we come to the end of the part 2 of the conference, which was about showcasing products, platforms, solutions. So we've seen a platform from CSFS. We've seen an implementation being done, POC and all implementation being done by a telco. And we've seen some work being done in a large network, engaging the community. If there are any questions, because we almost reached the end of, in fact, we've exceeded time here in Korea. Maybe the questions could be emailed to us, and we would relay them to the speakers. We meet again tomorrow for part 2 of the conference, where go to the master slide, where we will talk about some typical deployments, and also talk about the certification ecosystem, the compliance and certification ecosystem. So we do hope that you will join us again tomorrow at 4 p.m. Korea local time. Until then, see you. Bye-bye.